Hi everyone. So the first example of callable bond. So the example, a 6-year bond with $5 annual coupons is callable at t is equal to 345. So determine the present value so that the yield rate is at least 2%. Okay, so this is 6-year bond. So the time diagram becomes so 0, 1, 2, 3, 4, 5, 6. Okay. And the price is unknown, and $5 coupon every year. So $5, 5, 5, 5. And finally, we have redemption value. So nothing is mentioned, so this should be 5 plus 100. And yield rate is 2%, so I is equal to 2%. So at least 2% it says, but basically we just determine P when I is exactly equal to 2%. So if P is smaller, then of course yield rate is higher, but the present value there should be exactly corresponding to I is equal to 2%. Okay, so how to determine the P? So the point is that the issuer want to maximize the bond, the profit. Okay, so issuer maximize the profit. So that means that we have to choose the lowest possible P for all options. So issuer have the 4 options: call at 3, call at 4, call at 5, and don't call. So matures at 6. So issuers wants to maximize profit. So we want to compare those prices, and we have to choose the lowest one because the issuer wants to maximize the profit. So that means the issuer choose the least valuable option for buyer. So P should be the minimum of these 4 choices. So issuer maximize profit. So it's most beneficial for issuer. So least beneficial for a buyer. So determine the minimum value. Minimum possible P among all options, all choices. So we have 4 choices, so we just compare those 4. So if the bond is not called, what happens? If not called, just this is present value of usual bond with $5 coupon and the $100 redemption at time 6. So P is equal to 5 times A right angle 6 at 2% plus 106 years of discount, so 1.02 to the 6th power. So this is equal to 28.01 plus 100 times 1.02 to the negative 6. So this becomes 116.80. Okay, so this is 1. Okay, so how about if the bond is called at t is equal to 4? So if called at t is equal to, sorry, maybe 3, 4, 5, so 5 first. So then what happens? So then P is equal to 5 times, so it's called at here, so 100 just becomes here, then this disappears, so just 5-year bond. So P is equal to 5 times A right angle 5, 2%, and 100 times 1.02 to the power negative 5. So this becomes 23.57 plus 90.57. So this becomes 114.14. So actually this is lower than the last one. Okay, so how about called at, okay, so if called at t is equal to 4, then p is equal to 5 times a right angle 4 at 2% plus 100 times 1.02 to the negative fourth power. So this becomes 19.04 plus 92.38. So this is equal to 111.42. So this is number 3. So how about it's called at t is equal to 3? Okay, so the last case. So if the bond is called at t is equal to 3, then p is equal to 5 times a right angle 3 at 2% and plus 100 times 1.02 to the negative third power. So this is 14.42 plus 94.23. So this is equal to 108.65. So 108.65 is lowest among these 1, 2, 3, 4. So the price should be 108.65. Okay. So this is the answer. Okay, so is it possible to interpret it more intuitively? So can you see when the bond is called more quickly? Then actually, yes. So yield rate is 2%, right? But the bond pays 5% coupon. So basically, the issuer wants to stop paying coupon as early as possible. So because of this, argument, actually you can immediately decide that t is equal to 3 is optimal. So in some questions, this is less clear. But for this question, if you get used to the examples, then you can immediately see t is equal to 3 is the best. So just I want to mention that if the issuer will call the bond as early as possible. As early as possible. Because they want to stop so 5% coupon when the yield rate is only 2%. So this means that the t is equal to 3. So maybe this makes the calculation faster. Okay, so this is the first example of the callable bonds. Okay, so see you then.